Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. All right, hello and welcome everyone. My name is Charles Johnson. I am the host of It's a Controls Problem. I'm here with the business as usual, Matthew Vanberg, and we have a special guest here today, Jacob Jackson. So, hello, Jacob. Welcome to the podcast.
Thanks for having me, Charles.
Oh, you're welcome, and it's my pleasure. I've known Jacob for a little bit now. I met him at Niagara Summit last year. And then I quickly came up near Virginia to give a Niagara training where we talked some more, and we've become pretty good friends since then. But Jacob, I tell you what, let's go ahead and just go ahead and introduce yourself and why you're here on the podcast today.
So I'm a controls guy. When you have a podcast that says it's a controls problem, I took an interest. You and I have been in the business for a long time and kind of shuffled around each other. Lately, I have been kind of moving out of one space and moving into another for controls, particularly that Division 25 area. And I think what kind of got your attention is that I released a book recently called Smart Buildings by Design, how the fourth trade connects it all with the Purdue Model.
Yeah, you caught me, sir. You caught me, sir.
Okay.
I always like talking to you, but yes, this one was definitely more of a purpose here. So I tell you what, just to get a little bit of a background about you, I'd like to ask a few questions, typically, just to kind of get people in the feel of it. So, like, when you're looking back in your career path, like, what was that pivotal moment, or was there a specific project that sparked your passion for truly integrated building systems?
Ooh, that's a good one. So a very, very, very long time ago, there was these things called Palm Pilots, and I had one, and I just thought that would be so much easier to put one of those in my back pocket rather than pull out the 40-pound laptop and take it out to deal with an Andover AC256 and upload the program into that. So I started looking at how to use that Palm Pilot to be able to plug in, because there was nothing special about the Andover. I mean, it's a RS-232, plug in and just type in your text. There was no editor or anything. It was all online. So that was probably the first time that I sat there and thought, there has got to be a better way to do this. And from that point on, it just every time something came along where you could integrate it, you could tie it back together, you could use a better tool, I kept looking for a way to make that happen.
You know, it's interesting that you say that. One of my, when I became kind of like that independent contractor and kind of really wanted to explore more, it was actually because of I was doing a project with reliable controls, and there was an ALC web control system, and I had to get my reliable control system talking to the web control front end. And so for me, that's where that was the turning point for me that actually was that actually said, okay, I'm going to get more into this and learn everything about systems. So was there a specific, so the reason why I bring that up was there a challenging project or where there was a lack of integration that led to like a huge setback or unexpected problem that you had?
Yeah, so I was part of the facilities staff for a large campus. We had multiple different control systems. We had Allen Bradley, we had Andover, we had Stapha, we had something called Bucks, which I've never seen outside of New York City. And then we decided we were going to move to Siemens. And Siemens had bought Stapha, so the theory was is that we'd be able to just get the existing Stapha stuff, which I think on the campus we probably had 4 or 5 buildings that were already Stapha, and we should be able to just integrate it into Siemens, and it should just work, right? And it didn't, and it just became this ongoing nightmare. And I was pretty junior at the time. I was just watching everybody kind of, go crazy trying to figure out how to get this server system. It's the first time we'd had a server system that, make it work with the Stapha. And my boss gave me the manual and said, "Hey, here's the manual. Once we get it up and running, you're going to need to know how to make it work. So why don't you just read the manual and figure out what it's going to take once it is running?" And I read the instructions and I was like, yeah, this has got a tool to be able to integrate stuff. You just have to make sure everything's lined up and named right. And I don't think they did that. So without anybody's permission, I just deleted the existing non-functioning Stapha import and then used the tools that were provided and imported the Stapha database into Siemens and reset up the COM parameters and had to tweak a few of the alarms, but all of a sudden it was working, everything. All the graphics migrated over, all of the schedules, all of the alarms. And my boss and his boss came in and they looked at it and they were completely and totally dumbfounded and just asked, "What did you do?" And I said, "I followed the instructions. They're right here on like page 3 of the manual."
Reading does in fact explain a lot. It really sometimes
reading's hard.
Yeah, like sometimes people get into that. They will overlook the simplest thing first, and it literally could have been, like you said, like in the very beginning, but they brush over it, thinking nothing of it, and then all of a sudden, that was actually the most important piece of information that they needed the whole time.
Yeah.
And you're like, "Oh, I brushed over that 6 weeks ago. Man, I wish that would have sunk into me more." Yeah, those kinds of projects right there are really the time where you make that risk, that calculated risk, right? Like you decided, okay, I'm gonna start from scratch. I'm gonna just do this and come back forward and make this big leap of faith, basically. And you really kind of gave the why, behind of what you did. And I think that's really important for people to understand that, sometimes you kind of have to ask for forgiveness rather than permission. Sometimes, unfortunately, starting from scratch is really pivotal to make sure that you have something that's successful. And sure, people may see it as a huge setback, but it really isn't that much of a setback if the end result is actually really successful.
And it's not a setback if it didn't work to begin with. I mean,
that's right.
It was a non-functioning system. So what did we step back from? 0.
Yep. No, you're not wrong there. I think that's really a good point. You're like, well, it wasn't working to begin with, so you're welcome. I made it.
Yeah.
I did the thing to make it work.
Right. And if you took a step towards a direction of a solution, even if it's wrong, it at least cancels out one of the things. Okay, we know that doesn't work. Now it's on to figure out a new process for the solution.
Yeah, the saying is 2 steps forward, 1 step back. But if you're against the wall, there's no stepping back. So any step is going to be a step forward. So let's go ahead and try.
Yeah, absolutely. So again, the reason why you're here is, you obviously put your years of experience in this book, Smart Buildings by Design. So what was the single most compelling reason that made you realize this book needed to be written? Why? What story were you tired of not hearing in the industry?
Because we're doing it backwards. We keep doing this where we go from the ground up. We're like, okay, I've got a air handler and I've got some VAVs. Now let me go put a visualization on top of that. And then somebody comes along and says, well, now we need to do fault detection and diagnostics, or we need a dashboard, or we need some kind of reporting. So let's put that on top of that. And we keep building up. And the problem is that that's not the way we're building buildings anymore. You walk in and the client tells you, hey, our CMMS is going to be Maximo. So whatever you do, it's got to pull up into Maximo. Well, they just told you the business requirements right there. So build down. You know what their top layer has got to look like. You know what they want done. Okay, well, if they're doing Maximo for maintenance management, probably ought to put in a fault detection and diagnostics so that Maximo doesn't see as much and the facilities guys look better. They're not going to get dinged in this reporting system. So let's add that in there. Okay, now we're doing fault detection and diagnostics. What systems do we know are going to work with that? Oh, wait, just before we do that, that's all in the cloud, and this is going to be going on-prem, so we need to put in a security layer. So let's put that in there. Now let's go ahead and put in, what systems are going to work. Well, we can't use X company because they don't export to a fault detection and diagnostic. They own their own, and it's internal to their system. They're also not going to export to Maximo, so take that one off the list. What are my other options? And start building down. And you start to figure out that when you do this business case or top-down approach first, the systems are a lot cleaner and the customer is happier. They know that what they're getting is what they wanted because you told them, oh, okay, Maximo's you're in. All right, here you go. We're going to make your stuff work with Maximo. That's the problem. That's what I got tired of dealing with, is that we're backwards. We've got to turn around and go the right way.
So do you think that part of that, do you think that is a lack of foresight from the, from the designing perspective, where like they just, they may hear, they may hear Maximo, but in the end, they're just doing, they're just representing XYZ, so they don't necessarily care about that until it's in front of their face?
Yeah, and I think it's across the industry. Number one, Maximo is a business tool, and I use that one. That is a big one, But it could be the same thing if it's a dashboard requirement.
Right.
It could be the same thing, but that requirement is an IT or a business case requirement, and that doesn't get translated to the engineers who are designing the building. It doesn't get translated to the mechanical contractor. He hears that and he's like, that's not my problem. I'm not doing that. And then it gets to the controls guy who's doing it. And we're assuming there's no MSI involved in this. So it gets to the controls guy, and the controls guy's like, well, that's great that they want to do that, but nobody paid me to do that. That's nowhere in my scope of work. That requirement was not even listed because it doesn't translate down. So, yes, it's a lack of foresight, but it's also a lack of having the proper tools. So I am big on top-down approach, and Division 25 is got to be the way you do that, and everybody's got to know that they're working towards that Division 25 goal.
Yeah, I think that's a good point. I think there are many solutions out there that should be a top down rather than a bottom up. I think that there are a few corner cases which I think you need to implement from the bottom up first to get the to get to the top. But yeah, I think you've hit the nail on the head. Where if you already know the end goal, then that should be where you start, and then everything else can fall into place from there. So no,
Yeah.
I think I think it's a really good perspective that you bring to it, and it's not one that a lot of people really. I think it's a hard concept for people to grasp, especially because some of them are just not used to being exposed that way.
Yeah, and it's expensive lesson to learn. We had this happen. This has happened more than once. So you would think that we would learn, but a lift station. It sits right
Mhm.
outside the building. It's integral to the building. And so they want to get the alarms back in. And usually they tie it into the HVAC system, the building management system. But invariably it happens that nobody remembers to list that requirement and pass that down to say, hey, that lift station that's past the foundation, past the exterior walls, and is 500,000 feet out in the middle of this field, it's going to need a conduit with data coming back in, and it's going to need some place to land so that we don't have a light and a horn that sounds to tell people that the sewage is overflowing. Can you make sure that gets in there? And instead, they just completely forget about it until, the owner comes through and is like, hey, that light and that horn, that's not what I wanted. Or it's a year later and it overflows for the first time and they've got to clean up the sewage. And then they find out that that's going to be a $50,000 change order because you've got to trench to get a conduit in. And it's not just a simple trench. You've got to avoid the power that's going out to it. You got to avoid the sewage line because that's why it's out there, is to take the sewage out there. You got to penetrate the wall of the building. You got to patch all that back, reseed, all that sort of good stuff. It's not a simple ad. And I can't tell you how many jobs I've been on where that's like a punch list item that somebody says, hey, get that onto the control system. And you're like, no, that's not punch list. That was a key design criteria that you should have brought up very, very early to make sure that that's part of the system.
Yeah. No, absolutely, and I've seen some disasters like that too. I mean, I've been in the industry for, I guess you and I have probably been in the industry a collective of what, like 60 years, if not a little more.
Yeah, let's not
Probably.
lie about our age too much.
Yeah, we have we have the days of before even DDC
Yeah.
under our belt for sure. So I tell you what, in your book, Smart Buildings by Design, you actually introduced the concept of the fourth trade. So can you actually talk about what the fourth trade is and why it's so crucial to modern buildings?
So the fourth trade is a collection of all of the low voltage. It's also sometimes called the technology trade. And the thought here is that we're not siloed. It's not just building automation. It's not just security. It's not just lighting. All of us kind of have to work together. Right now, everybody's talking about the edge and, control on the edge. Well, how do you get on the edge? Well, that means you've got to be on the network. So the network is part of that fourth trade. So you've got to have that discussion about the structured cabling, the fiber optic backbone, the drops that you're going to require for all of your control systems. And then our control systems have to work with each other. So the lighting controls are going to tell, the occupancy for the HVAC system, or the elevator is going to tell it, or the elevator is going to tie into the access control to say that it can go to that floor. So all of those different low voltage systems that we've always treated as disparate, they're going to work on their own, they fall into that fourth trade. And they all need to be coordinated together to reduce cost. And honestly, at this point, just to make them function. Like I said, without a data drop, none of your edge stuff is going to work because there's no edge to attach to. And they work together. So the fourth trade, that name has been around for, I don't know, maybe a decade or so. But we're finally starting to get some traction with MEPT, so mechanical, electrical, plumbing technology. So that all lumps together under that technology fourth trade, and it should be coordinated. The drawing should come out from the engineers that way. There should be a master systems integrator who kind of makes sure that everything's going together right, that the fiber's in, the Ethernet drops are at the right place, the access control is handshaking with the transport systems or with the lighting systems, or all of those things are happening. So you might still have your specialists who do it, but they all work together under that fourth trade.
Yeah, I think that's also another solid point that you bring up. It's amazing how you hear what people want, especially people talk about the edge and they talk about clouds and they talk about all that, and then when you actually explain the infrastructure that needs to be put into place, and then they realize they don't have that infrastructure in place, they're like, well, now what do we do? Well, it's something that you should have thought about initially, and I'm sorry that you didn't think about it. And now, the implementation is going to be significantly more expensive than had you thought about it in the very beginning, like you wanted.
Yeah, and you can't do that to owners. You can't give a hidden cost. And it's irresponsible as a trade to know that what you're pitching to them is not going to work because you don't have all these other things in place.
Right, and to me, I've used this quite often on this podcast, and actually in people that I talk to. It's being that trusted advisor, right?
Yeah.
Like being able to go in and immediately talk to the customer even before the project begins. Like, hey, what is your end result? And then when they're like, well, I want X, Y, Z, I'm like, okay, well, we need coordination with this, and this to get it to work. Right, like it's that kind of work up front that I think that I've seen some contractors that just don't bring it up, and they're like, well, we'll bring it up when we need to bring it up. No, you should have brought it up at the very beginning, and you didn't, and that's a disservice to both them and the customer, because now now people, they're like, well, we don't necessarily while that part should have already been covered, the project is quote unquote complete, so then people charge change orders, and I'm like, ooh, I don't even know if that should have been a change order to begin with. Yeah,
right.
The project is quote unquote complete, but was it really complete if that was really missed? Right? Like it just seems that there was an oversight in the project, and it can get pretty hairy from there.
Very fast too.
Yeah, I think I'm glad that you're on. I am so glad that you're on this podcast. Like, with the with other I've loved every podcast I've done so far. I really have, but I think being able and we're kind of just this high level talk. I just want to say, like, I really am enjoying it. Also in your book, and you actually mentioned it, I believe, at the very beginning of this podcast, you mentioned the Purdue Model. And the Purdue Model is a significant framework in your book. So can you tell the audience about, what the Purdue Model is, and what about that moment where you realized its profound impact in the world of smart buildings?
So the Purdue Model is a system of describing operational technology that creates it in levels. So the concept is pretty simple, that there are levels 0 through 5, with 0 being the physical level and 5 being the cloud. Level 1, 2, 3, then you get into this little band in between 3, and sometimes there will be a level 3.5, which is the bridge from the on-prem devices to the cloud. So some people call that level 3.5 the DMZ. Some people don't even talk about it. They're like, there is a bridge between there. And then level 4 is your first software as a service layer. And they give it 2 layers to be able to say that there are some functions that happen at 4. And then there's an enterprise level at 5 that might cover more things than what was handled at level 4. And then I've kind of taken some liberties with mine that and I don't mean that badly, but I had to enforce some rules as I was writing the book. So a level 2 device has an Ethernet port. It has to have an Ethernet port. A level 1 device is just serial. And then a level 3 device is Ethernet, but it talks to multiple level 2 devices. And the reason for that is because we kind of get a little funny with how we name things in building automation, AV, lighting controls. So the model kind of forces you to think about, where are things going to sit? Is it a physical device? So level 0, physical. That means that it is a sensor, it's a relay, it's an actuator. So that all kind of makes sense right there. Level 1 means that I am talking to those physical devices, and the only means of communication I have is a serial port. Or I guess you could also have a LAN port on there. That would still be level 1. But those things have a very defined communication pattern. Then level 2 has an Ethernet port on it, but it can also have a serial port on there. Level 3 talks to multiple. So it builds this structure where it's very easy to go in front of an IT team for a building owner and say, hey, Mr. IT guy, here's our model that we follow. And they look at it and they go, oh, yeah, this makes sense. It looks like what I'm used to seeing with other IT related projects. So I can follow this map. Now, the other nice thing about the Purdue model, it has been adapted. It's the basis for ISA 95, which is the industrial standard. So if people are industrial automation guys, they look at this and they go, oh, yeah, this makes sense. It follows the same model I'm used to. It's also the basis for IEC 62443, which is the cybersecurity model. So people who are looking at it from cybersecurity look at the Purdue model and go, oh, yeah, this is exactly what we're doing too. It's got the exact same layout that I was expecting. So it's a common model that we can use, and it doesn't require me to get into naming of certain things. So there's a lot of talk right now about ontology, which is very important. Do not get me wrong, very important. But it's not something you can just take and, like, I've got one page in my book that is a diagram of the Purdue model. And it's very easy to look at it and go, oh, yeah, I know where that's going to fit on this model. With the ontology, you're describing it and saying where it's going to go. I was trying to make this as simple and as relatable to as many different practitioners as I possibly could. And Purdue was, created out of the university system, so they like for people to copy their work. So that makes it, more appealing because I'm not stealing anybody's anything.
All right. Actually, I have a follow-up question about your levels there. I don't know how much you are familiar with T1L, and obviously Honeywell has made a splash with it. And obviously Allerton,
we
which
lost
is owned
him for a second, Matthew.
Did we lose you, Charles?
Oh, can you hear me?
Hey,
yeah, we can.
Okay.
Yeah, we lost you for a minute. Must be the storm.
Oh, okay. I was just laughing for the most part, so it's no big deal. So T1L. Where do you think that fits? Because obviously now, like, because you're talking about like your level ones, right? Like your level 1, 2, and 3, and so obviously T1L is starting to make a splash in the BAS industry. Obviously, Honeywell has a product out with it, and obviously Allerton has now said they do. But obviously, Honeywell owns Allerton, so I would expect them to have it. Where do you think T1L fits in that Purdue model?
So it's a 10 base, so that kind of means that it should be Ethernet. So it should be at level 2 or above. It's going to kind of depend on how it's implemented. So if it's only Ethernet on there, then maybe it's a level 3 device. But if it's still got serial on it, I would put it at level 2.
Okay. All right. Yeah, I figured I would just throw that out there. I was thinking about it as you were describing, as you were describing the levels. Because like one thing I think is kind of interesting that people are like, oh man, have you ever heard of T1L? And I'm like, you do realize that is old technology. Like that technology has existed for years.
Yeah.
It's just that now someone has come up with an application with it. So beyond let's not talk about technical aspects for a moment, or beyond the technical aspects. With the smart buildings by design touches on the human element and collaboration. So can you recall a specific example where bringing in disparate teams or maybe even the stakeholders together for an integrated solution provided a challenging but ultimately led to a very surprising success?
Yeah, so I did a stint for a while working in audiovisual as the main vertical silo, however you want to call it, and worked with some good teams. And they wanted to take and have the AV system work with the shades, with the lighting, with the HVAC in the different control room, conference rooms. So that provided some challenges because I kind of use this analogy that HVAC is the big brother of controls. It's the 800-pound gorilla. They kind of know how to do everything. But AV is the flashy little sister because it always looks good. And everybody's paying attention to the AV system. They could care less that the HVAC system is running if the AV system isn't working. So you have this flashy little system and it's trying to coordinate and make the shades in the room work, and it's trying to get the lights to work. And the shades are a relay-based system and the lights are Dolly, and then the HVAC system is BACnet, and you're trying to get all of this to work together. So I was working with AV. Crestron was the manufacturer. They said they could do it. They had their own thermostat, but they didn't understand we're in a commercial building. So it took a lot of effort, but they wound up putting together a BACnet IP module that they could put on their AV controllers. Once we got everybody in the room and we started to understand what the scope was, things got a lot better. But it probably took a good 2 years to get everybody to figure out and understand what the client's vision was. That they didn't want everything on the wall. This is a high-end conference room. They want it to look very architecturally clean. So they've got this flashy touch panel sitting on the conference room table, and they want to be able to walk up to it, and they want to be able to start the conference, and it closes the curtains, it dims the lights, and it tells the HVAC system, we're going to be in here, and so you need to cool it a little bit more, or if you're in the meeting and it's a little too cold, they can just tap a couple buttons and raise it. So that coordination, this was early 2000s we were doing this. That took a little bit of effort to kind of get everybody to understand that, here's our vision. Here's the tools we need to be able to do this. Now you've got to go write protocol drivers and you've got to adhere to certain rules. Great that it's BACnet, but the first iteration that they came out with, there were some challenges. It was not a BACnet compliant device. And then the HVAC system also was like, yeah, we can take BACnet. And they meant they could take BACnet MSTP, not BACnet IP. So it's working through all of those hurdles and getting that to function. And this was for a large corporate client, and this is their marquee headquarters building that they're trying to show off, and they want everybody to see, and they want it as simple as could be. So those conversations about getting that out there and then going back and talking to the equipment vendors, you can be an absolutely brilliant programmer, but if the port doesn't exist, there's no way it's going to happen. So you needed the manufacturers to kind of support you.
So it actually really brings an interesting thing about integration. I think integration is one of the toughest things that you can do. Obviously, some are simpler than others, but integration to me, I'm not a fan of it, to be honest. Like, obviously, we need it, but and really everything's an integration, right? Like when you break it down, everything's an integration, regardless of what it is. But like the idea of product A plus product B plus product C. Oh yeah, we can all bring this here and it's going to work seamlessly. And rarely does that ever happen. Let's even talk about an older protocol like Modbus, right?
Yeah.
Where oddly enough, it's actually my favorite protocol to integrate over BACnet or LON. Without a doubt, I actually love it because of the complexity. But one thing about Modbus integration that a lot of people don't understand is that I think what makes it the most frustrating part is due to documentation. Each manufacturer may do Modbus a little bit differently, and even worse, they may do Modbus differently from device to device within their own company.
Yeah.
And so at that point, you're like, well, I have this Lochinvar boiler that I'm talking to Modbus, and they're using decimals, for their Modbus, for their registers. But here they've got another one that's using hex, and now this one here is using a different byte order. It's using big endian, where the other one's using little endian, and this, that, and the other, and it gets quite. It gets quite frustrating. And so I see why a lot of people give up on some of those things. But it leads me to my next question. Like, what's one piece of advice that you wish someone had given you early in your career related to the challenges of integrating these complex building systems?
Work from the end results and go backwards. So define what success looks like at the beginning of your project and work to that. So that sounds crazy. It sounds like, well, yeah, that's what we all do. But no, it's not. What is your business goal? What do you want to accomplish out of this? And then take a step back and say, okay, to do that, I've got to do this. To do that, I've got to do this. I worked for a guy named Scott Walker for a while. I love Scott. He's absolutely brilliant engineer. But he's also a great sales guy. And he had this line. He's pulled us all into the conference room, and he played a clip from the movie Airplane. And it's where they're trying to land the plane, and it's just an absolute disaster. And the tower is still giving instructions long after they've crashed and they're in the building. And Scott gets done playing the clip, and he's like, guys, it doesn't matter how well you take the plane off. It doesn't matter how well you fly it. It doesn't matter how good your service is while you're in the air. All anybody ever cares about is how well you land a plane. And I wish I had learned that so much earlier in my career, because it's totally and completely true. Nobody cares anything about how a project starts. They care how it ends. If it comes in peacefully, smoothly, you hand over all the training material, all the documentation, the warranties in place, they're happy. They don't care that there were bumps getting it into the air. They don't care if the service wasn't great while you're in the air. They're happy that they have arrived safely and they have had this pleasant onboarding of the plane.
Yeah, that's. I tell you, when you talk about that, I just recently one of my last trips. It was terrible. I was so glad to get off that airplane. I was so glad that it was really rough. But you're right. When you're at a project and you see everyone running around with their head, like chickens with their heads cut off, and then there's all this bickering back and forth, but in the end it's just all peaceful. It's like, oh, well, that wasn't so bad, was it? And then
Yeah.
you realize it was a knockdown, drag out fight. But now, I think of Sam and it was a cartoon. It was a dog and a dog and a was it a dog and a wolf, or where they were friends, but then they clocked in and they just kind of went to just going to town on one another, and then they'd clock out and be friends again. I think kind of that thing right there would be a good. I can't think of the name of it right now, but maybe it's just a bad example. But I think that's right though. You make a great point when you're talking about these kinds of projects, especially when it when it comes to fruition. I think as long as the end result that everyone ends up being happy, then it doesn't matter how you got there, right? I think
mostly. I've lived through some bad projects where crash and burn. We all have them. Those you really struggle to recover from. You also have the projects where there are some seriously ruffled feathers and there's some challenges. You'll remember them. Hopefully you just won't do those things again. So, yeah.
Yeah, that's that is one. I remember I did a commissioning. I took over a project from someone. We let them go, and we had also let the technician go. So we had never been on site before. They didn't give us time to do a site visit. They're like, "Hey, Monday morning, you have to be here for commissioning." Okay, all right. This can only end one way. And I told them that, and they're like, "No, it's going to be fine." I'm like, "No, it's never going to be fine." I get why we let them go, but we shouldn't have at that point. So the commission agent comes to me and goes, "So Charles, how is this going to work?" And I said, "Exactly how it's programmed." And he goes, Are you trying to be smart?" I was like, "No, I literally know nothing about this project. So you and I are going to learn together about what we're gonna uncover." And he came out with a 300 item punch list.
Oh, God.
And now, after about 2 months of going back and forth, the customer ended up being happy. We ended up making the commission agent happy, which I didn't think could ever happen. But we ended up having to actually rip out the controls and put new ones in. He failed the controllers because he didn't meet the specification. But yeah, it's one of those. It is one of those stories where you're just like, "Oh, it is just so rough." One thing that you mentioned at the very beginning of the podcast that I kind of thought was interesting is you talked about a Palm Pilot, and you had your AC 256, and you had wished that you could have just taken out your Palm Pilot and did everything that you could right from there. So looking to the future, what is a smart building scenario that you envision that, while might seem far-fetched today, do you believe is actually achievable through the principles that are outlined in your book?
I think the integration is coming along far faster than people realize. And I don't want to be a hype guy, but I'm going to be a hype guy right now. I think we are going to very quickly start to see AI tools moving in. And I think you're going to be able to sit down with some AI tools, and I can just imagine different things that are going to happen. But from the book's perspective, you will be able to use an AI tool sitting up at the level 5 layer, and you'll be able to say, "Hey, tell me the occupancy of my buildings and break it down in 5-minute chunks and give me a graph of that." And let me know what kind of the flow of my building is. And I think that the AI will be able to use a fully integrated building and be able to tell you that, your building goes through these cycles and here's when most people arrive and here's what there's going to do. And you'll be able to drill down and you'll be able to see, okay, it knows that because it sees the occupancy sensors for the lighting system go off. It sees all the swipe ins on the card access system. It sees the transport systems, the elevators, the escalators. It sees that the electric draw on those goes up during those times. It sees the load on the HVAC system. And it's going to be able to take that data and pull it together. And then you'll be able to do some things like, hey, what would it do to our energy usage if we said we were going to start an hour earlier or we were going to start an hour later? What would that do to our energy consumption and how much money could we save? And I think you could use an AI. And I don't think this is very far away. I think this is 2-3 years away where you could throw an AI that question. And because the building's integrated right and the data's accurate, it's going to be able to go out there and tell you exactly how that is going to work. And I think it's also going to be smart enough to tell you, hey, and by the way, I would question this building over here because the FDD has been going off and saying that this stuff's out of calibration and your maintenance guys haven't gotten to that. So that building's the one that I'm going to take and remove from this whole thing. And I think the AI will be smart enough to do that.
So I will tell you, or what I legally can tell you is I can tell you for a fact without breaking anything that scenario you just mentioned is not that far off.
No, it's not.
Not at all. As a matter of fact, probably sometime next year, you're going to see something that's very, very similar to that becoming more popular. Very, very similar. Something that I was showcased. And it was quite nice. Like there are some things they need to there's some things they need to take a look at based upon some recommendations from people. But yeah, you're not that far off. AI can be very controversial to some people. Obviously now there's a lot of things about vibe coding that have come out. Especially now with the controls industry and people wanting to do like a lot of Java, a lot of like Niagara program object or module development, and they're trying to use AI to do that. I think AI should be used as a tool, and it can absolutely show you things that you probably didn't know about before. But I think what's really important is to actually have a good fundamental understanding of it in order to utilize AI to the best of its ability.
I agree with that. I'm going to push back on the vibe coding. I think vibe coding has its place when you're dealing with air castles. You're working on true data-only projects.
Yeah.
I had a guy who worked for me long time ago. And, we had gotten it set up so that we had communication all across the campus, and he was supposed to be commissioning an air handler. And I found him at his desk, and I was like, I thought you were commissioning the air handler over in such and such a building. And he's like, I am. And I was like, no, you're not. You're over here. And he's like, well, I'm working on the code. And I was like, oh, okay, well, you've got to finish something up. And okay. About an hour later, I get a phone call from one of the commissioning agents on the team. And she said, hey, I shut down this air handler. It's been turning on and off on its own, and it did it like 3 times. So I just killed all the power to it because I don't know what's going on. I can't figure out what's happening. So I went back to the guy who was supposed to be commissioning it and found him still in his office and, at his desk. And I was like, so how are you commissioning? He's like, well, I'm loading the code here and I run through it. And when it doesn't work, I'll take and fix the code right here. And it's like, so you haven't been over to be at the air handler as you're doing this. He's like, oh, no, I'm just watching all the sensors and watching, the inputs. It's more comfortable over here. I don't have to sit on the bucket in the mechanical room. And I was like, yeah, that's true. But did you know that you turned on and off the air handler 3 times within 10 minutes? And he's like, yeah, I was testing something. I was like, you do know that big VFD has a great big warning label that says you can't do that because the capacitors won't take that?
Yep.
What? I was like, yeah, there's a great big warning label on the VFD that says, you can only cycle it 3 times within 10 minutes. And then after that, you've got to let it rest for 20 to let the capacitors discharge.
Yep.
Nope. I didn't know that. It's like, you probably would have known that if you were in the mechanical room looking at it. All that to say, I think vibe coding is fine if you're not attached to real equipment. If you're attached to real equipment, all vibe coding is off. It's got to be, you got to watch your equipment. You got to have a real plan for what you're doing.
Mm-hmm. Yeah, the big thing, right now, like, I know of some technicians who have just tried to do everything like from their like right from their van or wherever, and I tell them, like, no, you gotta be in front of the equipment. You need to know. You absolutely need to know when something is going on, because, like, sure, you might be able to see it, but what if something got wired wrong, right?
Right.
So like even at that point, if you haven't done your point to point or anything like that, like, it doesn't. Sure, remote work is great, but sometimes being in front of what you need is the big thing, or having someone having eyes on it at the same time, right? Because let's face it, there are companies out there that have a programming department that actually work with a technician in the field, and so the technician in the field is actually kind of being their eyes and ears while the programmer is going through a checkout. But yeah, absolutely, something like that, without knowing the piece of equipment that you're in front of, it can get really dangerous.
And if you're at a company like that, you've probably got some chops where you've already tested that code on another piece of equipment before you decided to start doing this model where you've got a technician and a remote programmer. You know what your code's going to do. So now it's just a matter of checking out and making sure that the equipment matches what you expected it to do.
Yep. Yeah. I mean, those kinds of things. And especially if like, it's interesting. Like, you'll see like a trend right now where obviously you have a bunch of young people that want to get in the industry. And it's kind of hard because companies are looking for people with experience. And then, they're like, well, how do they get the experience, right? Like that's one thing that happens. But some of them just get, while controls was always, and still always has been baptism by fire, which I wish there'd be better training implementation from a company perspective, but that's a whole different podcast. Those people really need to understand why they're doing something in the field before getting into a computer completely. Like, how do you adjust a high static switch, right? Like, yeah. I was just going through with someone, like, hey, like, you need a mag gauge. I don't have one. Well, how are you gonna set up the high static switch to trip? Well, I'm just gonna turn the screw. Well, how do you know that you're not going to make a square duct round? You gotta use those kinds of things. So those fundamentals are really important. Thinking about the countless hours that you have spent designing and integrating, and now obviously writing about smart buildings. What is that moment of just pure satisfaction or accomplishment that truly stands out that you've done? And I know that you mentioned a few, but are there any others that you're like, you know what, I am proud that my name is on this?
Yeah, there are some projects like that. I've gotten to do a few museums, and those are really, really cool. Museums and like music halls, because they're kind of unique and different. You don't get to see a lot of those. I did a historic theater in Georgia, and that was kind of cool to be able to do some stuff because, you know, we had to make it match. So there was some artistic quality that went into getting the thermostats and then taking them apart and putting them into, you know, turn of the century enclosures to make them look like they belonged inside the theater. Instead of a blank wall plate, you look at it and you're looking at like this Honeywell thermostat that's from 1908 or whatever it is. And once you get into it, it's a modern thermostat, but it looks like it came from 100 something years ago. And then there's also just the functions of those buildings because, like with a concert hall, the air handlers have to be whisper quiet because you want to hear everything out of there. And then museums, you know, you get to play with the lighting to get it just right on the displays. So, you know, these museum directors, when they tell you that they want the lighting at 48% and they want it to be 3700 Kelvin and they want the HVAC set up for this and they want the AV system, and you get to integrate all of that, and then you tweak all of it together. Those are really, really fun projects. They will stress you out in the moment you're doing them because you're like, I can't keep all of this together. And then they threaten you with, you know, you turn the lights on too high and you're going to ruin this ancient manuscript. And you're like, oh, yeah. But when you do it right and it works and you can point back and say, yep, I worked on that. That's mine. I made all of that stuff come together. And every morning they come in and they hit that button and that's me that does all that. That is cool. That is so incredibly cool.
One of my favorite projects that I did was an archaeological exhibit. St. John's of Southern Maryland. It was actually on the campus of St. Mary's College of Southern Maryland. And the reason why they created this archaeological exhibit is because I guess they were doing some surveying on the campus, and they found this tree that apparently was that had something underneath, like some teacups or something. I forget exactly specifically what it was, but they needed to fund the entire dig. So what they did to fund it was they created this museum around, this whole thing. And so we got on the project, and the sequence of the air handler. There were two air handlers that served this. And they actually had like dew point sensors in the ground, dew point sensors on the wall, and stuff like that. Because obviously you want to be able to you want the ground to always draw more moisture than the air. But the way the sequence read was, it said, space temperature set point shall be at which relative humidity is at 55%, and space temperature dew point is 1 degree above reference soil dew point temperature. So, but like when you first read it, and then you're reading it over, and then you read it again, and again, you're like, how do I do that? Like obviously sometimes words are hard, and English is one of the most difficult languages, to learn. And it's even hard for native English speakers, because some people just don't English well. And so instead of just saying, hey, your humidity, you need to maintain 55%. And then your soil dew point temperature, that set point is 1 degree above it. We're done here. Right? Instead of just breaking it down simply, like it was so verbose that, when you're first looking at it, like it's hard for you to like kind of like take a step back and realize what they're trying to say. But the most interesting part about that was these were heat pumps, these air handlers, and they were water source heat pumps. Well, the VFD that they had, on the drawings itself, was actually supposed to have a pressure sensor actually tied to it, and the VFD was actually going to monitor the speed, or I'm sorry, maintain the pressure. So that didn't happen. There was no pressure sensor. And we were like, where is it? And they're like, you're supposed to provide it. I'm like, nope. Look here in this mechanical. It does not say this is a part of. At that point, that was, and obviously, I was back in my day. We had Division 15. There was no such thing as Division.
Yeah.
There was no such thing as Division 23 or even 25. At that matter, it was all, we were 15900. That was our specification. However, nowhere in 15900 was that even a thing. And so the mechanical's like, well, we're not doing it. And we're like, well, we have commissioning tomorrow, so obviously that can't happen. And these things need to be up and running. And then all of a sudden the balancer comes out. And we sat there for about 5 minutes, and we're like, let's go out to eat. So we all went out to eat, and we had a few drinks. And I can say this now because, I'm not going to get in trouble, but we were having a few drinks, and we're like, how are we going to do this, guys? Because we all have to be done by like tomorrow morning. And so we just kind of put our heads together, and basically what we did is we started, each air handler had 2 stages. And so we pretty much we started to ramp the speed of the VFD and turn on each stage of the heat pump. And as long as it didn't blow, the pressure relief, we considered the speed to be good. And so we actually did it that way. We worked on it for about 4 hours on speeds. And so when we needed one stage, we ramped up, and then after we got to that speed, after a certain time, then we brought on the first, we brought on that stage, and then the second stage, and so forth and so forth. So the next day, the commission agent, the same one that I had to deal with, that I was talking about earlier, that had the 300 item punch list.
Yeah.
He was the same commission agent. And I'm like, I don't know how this is going to go at all. This could go really well or really badly. And oddly enough, once I sat there and explained everything to him, he's like, I don't know if I could have thought of anything better. I was like, I was hoping you were going to say that. And it was actually one of the smoothest commissionings that we did. It was that was a sense of relief for me. Just like, you know what, that was really a good one there.
Yeah, I was going to tell you about the opposite of that though. I got a chance to judge like the smart buildings that came out of the universities, and it's full integration, and they basically have a tiny home, like a container size home. And I remember judging one, and I was like, this is absolutely great. Everything works. I mean, you got the shades, you got the lighting, you've got the access control, the HVAC. It's brilliant. And I was with another guy, and we're like, this is really cool. This is what these should be. So we sat down with the student, and we're like, we're really impressed. So what did you use for your underlying electronics on this? And they told us. And we're like, aren't those really expensive? That's like lab grade type stuff. And they're like, oh, yeah. And we're like, so what did this system cost? And mind you, this is 2012, I believe it was. And they tell me that this little system for a 400 square foot tiny house was $90,000. And it's like, whoa. What person do you think needs a $90,000 control system to run a 400 square foot house? I mean, the thought here is simplifying, making things easier, but making them work. So to your point about jobs you want your name on, and then there are jobs you do not want to be in any way associated with.
Yes, I've been a part of those too, where
Yeah.
I've had my hand in them. Like, they're like, "Oh, so you did that project?" I'm like, "No, I only did a portion of that project. My portion was successful, but you won't know that from the rest of the train wreck that was there." I'm like, "Please don't mention that I was even remotely a part of that project."
Yeah.
No, I understand that one completely. It's yeah,
The Alan Smithy.
well, it's like we all have our wall of fame and wall of shames, right? Like, like we all do. It's like, yeah, like we don't want to show people the wall of shame, though. I actually like to kind of give my students stories of my own misgivings that I've had, just because I don't want them to that I don't want them to follow those mistakes, because sometimes, as you know, we've had to learn things the hard way. Like, oh, like you thought it was a good idea, and then when it, like, oh, that was really really bad. And so, speaking of which, that's kind of one of my last questions I have for you is, for someone who's just starting out in the building automation or maybe the operational technology field, what advice would you share to them that might help them steer towards success?
Find yourself a good mentor. Find ways to play on your own. I'm not opposed to you getting a Raspberry Pi and finding ways to do little controls things with that at home. But play, and then tell your mentor what you did and why you did it, and get their honest feedback. Was that a good decision? Was that a bad decision? Is that a novel way of addressing the problem? Did you waste a ton of money and time trying to figure that out? But you need to touch it. You need to play with it. So, if you've got a friendly vendor that'll give you a controller and a programming tool, great. If you don't, go find yourself the cheapest thing you can find on the internet and start working with that, and just try and make things happen. But then have those conversations. Find your people that you fit in with and that you can tell them about that. I got a few guys I'm mentoring right now, and they call me with so many things. Mason will call me with the wildest, craziest ideas, and then I have to research them, and I'm like, okay, he's not as crazy as I thought he was. That is not the way I would have done that, but that is a modern solution to that problem. And then I've got others who are just very reserved, and I'm like, yes, I like that. That is exactly the way I'm doing it. And I would encourage you to keep doing it that way. And I know that's reliable. And then I'll look at what Mason did and I'll be like, yeah, you're crazy, but I like it too. Okay.
Did I meet Mason?
Oh yeah, you've met Mason.
Okay. Yeah. I thought he was the younger guy with glasses, right? In my, that always wore. I think he wore like flannel shirts every day in the class.
Everybody's younger than you and I, Charles.
Well, okay, that's fair. I mean,
yeah.
Okay, all right. That's you're not wrong. You're not wrong. Okay, that's fair. Yeah, I thought I remembered the name. Now, granted, sometimes it's hard in my old age, but yeah. Okay, I was like, the name sounds familiar for sure.
It's all right. I mix them all up and I call them by each other's names. So Mason, Blaze, Micah, and I don't know which one is there. I just called them that name that day. So yeah.
I think of South Park where Stan's grandfather keeps calling him Billy. Yes, yeah, that's it's one of those, like, I've got a few of those in the in my company, and they're hungry, they're smart, and so like I was like, until you earn your name, I'm going to give you, like, I forget what nicknames I've given them, but they go by that name, and they use it as a term of endearment. But they've been asking for a lot of guidance, and they've actually surprised me in some aspects. I agree, playing with things is really important. BAS Pi is a good one. With that having the daughter boards, even using homeassistant.io is a great one, but still using Raspberry Pi, and there are some other things that you can do with it. Unfortunately, people don't invest the time that it would take to get really good at something anymore. Some people just want to kind of learn it through osmosis, and I'm like, no, you've got to. There's so much that you have to do, and so you've got to invest some time in yourself to do it for sure.
Yeah, and there are so many things that, if you'll take the time and read the books and learn what's out there, you will be so much better, or you will understand why this doesn't work. Airflow sensors. I cannot tell you how many of them I've installed wrong, but if you read the manual, they tell you how to install them, and sometimes you just got to go back to the mechanical contractor or go back to the engineer and say, yeah, that device is not going to install where you showed it because right here in the manual. So it's never going to work right. And that's just one example. There are so many things that are like that. And you as the controls guy will get blamed for it not working, even though it was somebody else's problem long before you touched it.
It's always a controls problem.
It's always a controls problem. So you have to learn what it is you're dealing with so you can, A, defend yourself, and B, figure out a way to make it work so you don't get blamed.
Yep. You are absolutely great. And you're absolutely right on that too. It really is so important. I've got a bunch of different test projects that I have here at the house, and actually I offer some students who really seem that the younger ones that seem hungry. I actually give them access to some of that stuff.
Yeah.
And so I'm like, hey, if you need me to put this on here right now or do something, or if you want to get in, just let me know and I'll create a little sandbox for you. And so I've actually got someone in a little sandbox right now, and they're having a blast. I think like finding what excites people the most about a specific career path, I think is one of the ways to motivate them to become better. Right. Because like I feel like at times, I've done recently just a little thing on Baja script, and you see that I showed people that I've made a graphic without a PX page and stuff like that. And so be like, oh man, I really want to get into that. And I'm like, well, before you do that, why don't you actually start building PX pages first? Let's go ahead and start with that first. Then you can understand how it all works out. Then we'll get to this part. But let's start small, and then we'll get in the bigger picture. As well.
I agree with you on finding ways to play. I even do it now. And you know me, I have a big interest in cybersecurity for OT. Yep. So the government actually does some really good stuff out of CISA. And one of their events that I absolutely love is when they do the Capture the Flag event. And you're allowed to put together a team of, 4 people or something. And they give you a couple days as part of this program to be able to hack this sandbox system that they've set up. So I encourage people, look for things like that where you can be challenged, you can be engaged. And then, like I said, find your people that you can do it with, your mentors or some of your mentorees who are smarter than you these days. So just dig in and find ways to keep yourself engaged and challenged and frankly entertained with what you're doing. Because if you're not having fun at work, you're not worth working.
Having fun in your environment is absolutely one of the most important things that you can do, because it doesn't seem like a job at that point.
Right.
It's just you having fun, doing what you love, and you're getting paid to do it all at the same time. Go ahead.
And if you come down to you're just doing it by rote, I mean, yeah, great. All of us understand it. Sometimes it's duty and you've just got to do something. That's true. We get that. But if you're not finding something in your job that you're having fun doing, you're going to burn out. So you've got to find those things that make it fun, that make it interesting, that challenge your brain and cause you to learn something new. Because the industry is going to change. It's going to change around you. So you need to, find ways to keep up and make it fun keeping up.
That's one of my biggest things, and I think one of my biggest pushes from the development side, Jacob, is, you know, obviously we're dinosaurs in the industry,
Yeah.
and eventually dinosaurs fade, but it's really important for me to stay as relevant as possible, especially in my role as a trainer. It's really important to keep up with latest trends and my nose to the grind, my ears to the ground, and getting keeping as relevant as possible is really important to me.
Yeah.
Oh, sorry. Go ahead.
No, I was agreeing with you. I think that is exactly the case.
Last question, and we'll let you go. Because I have a feeling. What's your favorite control system you've worked on? Not a project, but what's your favorite controls?
I really like Andover's AC256. That drum programming, it's line code, so it's really easy to follow. The way they did the drum programming, it was unique and different. And I figured out ways to make that sing. And just, I've never seen anything else that comes close to it. It's just, it was simple, but it was powerful. So I love that. I like Niagara. Don't get me wrong. Niagara is wonderful. It's just sometimes I'd like to be able to sit down and write a line of code and just say, this is what it's going to do instead of having to draw it out.
Wow, that was not expected. I will tell you that was not expected. Everyone that comes on so far, it's been a unanimous Distech. And obviously, Distech is a robust product, and people like GFX. But Distech had a freely programmable controller that was line code. A lot of people don't realize that because they haven't been in the industry as long as you and I, when we were there for the very first control system ever built.
Siemens had PPCL, which was line code. It was really good. Delta has GCL. Yep, and that's really good. It's line code. I know you can line code using Java in Niagara. It just, I think it's something about your first real control language. And like I said, there were others. Stapha used ePlan, I think it was. So it was a diagrammatic, and I did not like that. Bucks that I mentioned earlier was diagrammatic. Didn't love that. There was a Honeywell system somewhere in there that we used. I didn't love that. ALC was cool. Web control was cool because that was the first time I saw a diagrammatic and it was like, yeah, this actually works. So I got it. But yeah, the first one, I got to go with AC256 drum programming.
I cut my teeth on Network 8000. And so a lot of people, they're like, they don't understand it because it's block code, but it's not graphical block code, right? So like you actually had to have a piece of paper and draw it out and then type out the blocks to put in there. That will always have a soft spot for me. I like Reliable as well. Obviously they have Control Basic, and Reliable and KMC, they're using the same Control Basic. Line code I think is more robust. When you're getting to things like Java and stuff like that, I think that's a little more difficult for people to understand, especially because of all the methods and API. When you get to that kind of thing, I think it's a little tough. Like Niagara had triple. I loved triple programming in R2. And as a matter of fact, ALC also has a line code called OCL Plus. If you wanted to make your own blocks, you could do that there too. Structureware currently has a way to do line code, and obviously, if you're dealing with like Continuum or whatever, you have plain English programming. So there's a need for line code, and I really like line code just for the fact that like I can do 30 things in one line. And then I can go into like subroutines and stuff like that, and just go to and just skip statements and stuff like that. For me, that always has a soft spot there.
What I do not want to go back to is ladder logic.
No. The days of DX 9100s with GX 9100. No, get out of here with that.
Yeah.
Why do you have 16 blocks and then the rest you have to deal with ladder logic? You're like, why? Why is that a thing?
Yeah.
I never understood it. Like, I was like, that's a European product, because they feel that they're better than Americans anyway. It's like, no, we're more sophisticated. We're going to do it that way. Yeah.
We're talking about this Crestron. What I liked about theirs is they had a diagrammatic, but then you could do some really cool stuff in what they called Simple Plus, which was this basic type language. But you could build everything in Simple Plus, and then it would create, like you said, a diagrammatic block, like what you were talking about with ALC's web control. But it was more C-like than it was basic. So it was pretty cool. And then they updated their entire model, which I wish some other controls companies would do. And they moved their entire platform to a C# base. So their stuff is actually kind of modern, and it's really impressive what they're doing. And that's, again, why AV systems are able to be the flashy, cool stuff, is because they actually have real tools. HVAC guys, please listen. You need to get some real tools. Yeah.
Yep. Well, Jacob, it has been a pleasure having you on this podcast. I really have enjoyed the conversation here, and I want to have you on as a guest again for sure.
Well, please do. I enjoyed this too, and we did not even talk about cybersecurity, and I've got tons of that in here. So maybe next time we can talk about cybersecurity and why it matters.
Absolutely.
Absolutely.
Yep. Yeah, we did one on cyber hygiene, but it doesn't. We love to have multiple episodes with the same topic to get different perspectives from people. So absolutely, we'll bring you on for that for sure.
That'd be great. Thanks for having me, guys.
All right, have a great one.
Thanks, Jacob.
All right, well, that's the end of this episode. Until next time, I'm Charles,
And I'm Matthew.
and this has been It's a Controls Problem. A little joke, and remember, Purdue is not just for chicken. That's not as good.
You just said it, and I might cut it in that little end segment.